Hello, welcome to Special Maths Academy. In this video, we'll be looking at solution to the just concluded Special Maths contest. For this problem, we'll focus on this equation first. We see that we can make x, y, or n subjects, but we're going to definitely have a fraction, especially when we have n equals to the subject. The denominator is going to be x minus y, x plus y, and that's not it doesn't look nice. It's the worst denominator we can actually have to work with. So this suggests that we don't want n subjects. We want to make n like some kind of constant where we write others in terms of n. So we'll take n as a constant, and then for this problem we have to work with the options, which will be another equation. So coupled with the first equation, we get two equations. So if we take two of them as variables, that means we can solve. So we just take n as integer greater than 3, that's constant, so it's an integer. Then from that we can always solve for x and y. So all we need to check at each time is to see whether x and y are integers. So now the question says the following are possible except. So possible meaning that there is a solution x, y, and n that satisfy both equations. Right. So if we solve for x and y and we ensure they are integers, we can, it doesn't have to always be an integer for every n. We just need to make sure there's an n where we can have an x and a y. Right. So we need to solve for n as well, and if it works for every n, then that's perfect. So in the first case, we see that this will also have to be an integer by default, and all we need to check now is whether the corresponding y will be an integer. So we just need to plug this into the original equation. So I'll just call this star. So if you plug this into star, we have n into 2n minus 1 plus y equal to 1. And to solve this, we'll see that we'll still have a fraction, which will be something like this: 1 minus this over n minus 1, which perhaps can be simplified. But the main what we need for sure now is just to make sure that we can find a value of n satisfying the condition, of course, whereby this is an integer. So it doesn't have to always be an integer. So this doesn't have to even be factorizable. We just need to make sure there's a value. So what we're going to do is to take mode n minus 1. And this is okay because n is greater than 3, so n minus 1 is greater than 2. So it's proper mode. We take mode n minus 1 and look at the numerator. We need to make sure it's going to 0. That means we can divide and get the integer. So this is all it takes. And that will be corresponding to taking mode n minus 1 in this original equation. And we expect it to be the congruency to hold, that's both sides being congruent. So once we can find a value of n whereby that congruency holds, then we are done. So let's take mode n minus 1. In mode n minus 1, we have n is congruent to 1. So from that, let's call this plus. So plus would give 1 into 2 minus 1 plus 0 times y. So we want to check when is this going to be congruent to 1 again. And this will be 1 plus 0, so that's 1 congruent to 1. So this in fact is always correct. This means that irrespective of the value of n we use, this will always be an integer. So in fact, that means this must have been factorizable, but I would not bother with that. Okay, so we just use the same approach for the rest of them. For the second one, automatically y this time is an integer, so we need to make sure that x is an integer. So we have nx plus n minus 1 to this is 1. So making x subject here, the fraction will be over n. So you just need to take mode n and check when the congruency is going to be satisfied. So mode n here, n is congruent to 0. So if you call this plus, then from plus we get 0 times x plus minus 1 times minus 1 congruent to 1. And see that this time around is also always correct. So that means it's possible for A and for B. Now the next one we have y minus x is 2n minus 3. So y minus x is 2n minus 3. So this time around, we don't have either of x and y, so we have to solve like simultaneously. But from this, we see that we can make y or x subject here without having to create fractions, and then we can plug that in into the equation star, and then we can solve for the remaining variable. Now the catch here is that whichever variable we pick, once we solve for the other variable and we make sure that one is an integer, then the second one will also have to be an integer because this is an integer. So if one is an integer, the other is an integer. So we just need to pick any one of our choice, plug it in, and make sure it's an integer. So let's say we go with making y subject. So that means y is 2n minus 3 plus x. So we'll plug this into star, and that will give us so we're letting y now, that will give us nx plus n minus 1 2n minus 3 plus x is equal to 1. So you just need to figure out the coefficient of x, because that's what will create a fraction. We come from n here, and when we expand this, we come from n minus 1. So the coefficient here is 2n minus 1. So this is the mode we'll be working with. And in mode 2n minus 1, we have that 2n is congruent to 1. So just keep this in mind and use it to simplify. So now we just need to take mode 2n minus 1 of this equation plus and see what it takes for that to be valid. So we have nx plus n minus 1. Then this will be 2n is the same as 1, so 1 minus 3 plus x. I want to check when this is congruent to 1. So we can simplify a bit further. We have nx plus, so this is minus 2. That'll give us minus 2n. Let me just expand this fully. So that will be, so this is minus 2 here. So that is going to give us minus 2n plus 2 plus nx minus x. It's congruent to 1. Okay. And here now 2n is congruent to 1. So, and we can group in nx and nx. So we have 2nx minus x minus 1 plus 2. And 2n is congruent to 1. So this is x minus x plus 1 is congruent to 1. So this is always true. So once again, we have that all the values of x of n, we're going to have integer for x and y irrespective. Now the next one we have option D. 2x plus y is 2n minus 3. So 2x plus y, 2n minus 3. So I'll try something similar. This time we don't have much of a choice. We have to make y subject so that whenever x has been guaranteed to be an integer, then y will also have to be an integer because it's a subject without fractions. So we have y is 2n minus 3 minus 2x. So we just follow the same procedure now. We have nx, n minus 1, 2n minus 3 minus 2x is 1. So this is a new plus. Then now we need to check the mode we are working with. So coefficient of x is the main factor here. So here we have n coming out, and coefficient of x here will come from multiplying this out. So that will be minus 2 into n minus 1. If you add that together, you're going to get minus n plus 2, or negative n minus 2. So this means the proper positive coefficient to be n minus 2, and n is greater than 3. So n minus 2 is greater than 1, so it's also a proper mode. So take mode n minus 2, and of course here n is congruent to 2. We use that to simplify plus. So this will be 2x plus 1 times 4 minus 3, which is 1 minus 2x. So I want to check where this will be congruent to 1, and that will be yeah, so when you expand this, you just get 1. 2x will cancel with 2x, congruent to 1. So this is also correct. So this means the final option will have to be E, but let's confirm. So for E, we have 2y x and 2n minus 3. So this time we'll make x subject, so that once we solve for y, we can be sure that x is also an integer. So look at plug this into star. So now we have n 2n minus 3 minus 2y plus n minus 1 y is equal to 1. So this is our new plus. Now we're looking for the coefficient of y to check when it's going to be an integer. So we look at this. Here we have this as minus 2n, and here we have n minus 1. So if you add that, we get minus n minus 1, which is negative n plus 1. So the right mode here is n plus 1. Okay, so in n plus 1, n is going to congruent to minus 1, and we use that to simplify plus. So this gives minus 1 into 2n minus 3 will become minus 5 minus 2y, n minus 1 in plus will be minus 2. It's congruent to 1. So I want to check this. So this means we have 5 here plus 2y minus 2y is congruent to 1. So 5 has to be congruent to 1, meaning 4 will be congruent to 0. So this doesn't mean it fails. It just means that the condition for this to work is n plus 1 will have to divide 4. So this means n plus 1 is going to be a divisor of 4, but then n plus 1 is greater than 3 plus 1, which is greater than 4. So we see that there's no there's no factor of 4 that's greater than 4, and that's where the inequality actually comes in handy. So this it's not possible for every value of n. And that brings us to the correct option, which should be option E. Okay, so that was a bit long, but I hope you enjoyed. So I'll see you in the next one.